Hello everyone, my name is Wade. We're going to share the blockchain analytics solution using Apache Doris. So before we jump into the details, I want to do a survey that anybody know about blockchain, please raise your hand. Okay. You know about the blockchain data structure, raise your hand. Yeah, good, thank you. So I'm gonna share some more detail and I explain some of the blockchain terms. Okay. So a little bit about myself. I'm CTO of Google Analytics. So it's kind of a blockchain data analytics company providing solution for the project domain on crypto domain. I'm also CTO of XCelsior AI, which is recently we developed this product for the next generation AI application for Google Spreadsheet. Previously, I'm a machine learning engineer and also a data scientist. I use machine learning technique for investment to gain 100% APR. Also, I'm also a crypto investor. Lots experience 100, almost all of my money on crypto. So, but I'm very happy to that I stepped into crypto industry and gained more experience, especially on the data side. So the content includes several parts. The key parts is a requirement from our side as a data analytics company, and also the key metrics we are for our cluster, and also for our architecture, and some of the advice for choosing setup for Apache Doris, and some of the materialized view, some of the features when you consider to migration, and also the problem you might have for the migration. So let's dive into what a company provides. This chart shows us that we ingest both Web2 data and Web3 data into our system, and then we normalize and standardize everything and to build our abstraction layer so that the client side from our company could get more easy to use data analytics and gain more easy to use insights, including project metrics, some of money flow checking, some of the usable file, some of the when you're growing your economic, when you're growing your economic of your project, you might need to how to gain user attribution, and you know your community, the sentiment of your community, and moreover, you as a marketer, you know how to grow your revenue and grow your company, grow your community, and some of the Web2 data, including Google Analytics, also some of the ads, some of the private database from such as your logs of your project. We standardize everything into our system. So our architectures follow the pattern of Lambda architecture. So it's quite a typical architecture. From the left-hand side, you can see that we have loads diverse data source, which came from S3 like storage, and also we fetch all the data from some of the as I mentioned previously, private database, and also some of the we call RPC, which is blockchain data service provider, which provided the raw data of the blockchain. So then we have two lines which separate from the streaming data processing and the batch data processing. In the middle, you can see that we have quite a mixed computation engine with both Spark and Chuno, and using Flink to sync real-time data into our OLAP Doris. Some of the term using bronze or silver or gold, using the concept of Databricks, which means kind of raw data, DWD, DWS, or LTS layer, referring to the bronze, silver, gold. So the query engine we use is both stories and journal. And I will disclose more detail later of the setup. On the front end, we have a kind of a Tableau or UI, which is support the user to drag and drop and easy to gain the insight and customize the chart called open source project called Metabase. So we also support our API and using REST API and using SQL to query our database for our clients' analysts. So I will have a comparison of why we choose Doris. So first thing, requirement from our side. Before 2 years ago, we using Google Cloud, using BigQuery for our major data warehouse. But from then, we have a few clients that require low latency, especially from us pricing and trading related table that is a must for very low latency within minutes and low cost, low maintenance. As you know, we are kind of a startup company. We have less than 10 developers for maintenance the whole data structure. We have clients came from other companies as a data analyst. So it's a must-have features for low latency, low cost, low maintenance. Also nice to have features DTD support and community support. So this table, we have several options here, but in summary, Doris stand out for high concurrency, and is SQL support for XCelsior, which, as I said before, client side came from analysts from other companies. It will lower the barrier for them to use our platform to write some SQL code and for the migration from other competitors. So the performance is good. Operation cost, we have no experience of ClickHouse, and it scares us for the operation cost, and we don't have some transaction database when we mentioned about a TiDB. And we receive very less community support from Jew. So in general, Doris stand out, and we started to use back then 2 years ago. So key metrics of our setup and how the feature of we call the blockchain data feature. So blockchain is running globally. It's 24/7. So no peak hours. All of them quite stable. And most of the data is transaction, not log-like. So that means that user came from our analytics side, they query the historical data rather than you can see usually historical logs won't query by some of the company scenario, but from our side, user will query the historical data. So that means quite challenging for us to store some of the data and provide availability for the historical data. And almost most of the table are around 400 million rows. As you know that there are around 400 million addresses for each blockchain. So that means even some of the application table is around that size. For our setup, Doris and Chuno, we have 3 backend with 32 cores and around 100 gig and SSD. We have only 1 FE. I will explain later. The size is 10 terabytes and Chuno is around 200 terabytes. The core performance for this setup is around 400 for QPS. But at the peak hours, we have 1K. At that have around 6 B if I remember so. So a query per day is 3 to 5 million, and the percentile of performance at 95% is 7 seconds, and percentile of 90 is around 1 second. Previously, this number is almost triple when you're using BigQuery, and not mention about the latency. And for you first time using Apache Doris, the first thing you need to choose the data model. As previous speaker already mentioned a little bit about when you're choosing, you have 3 options: aggregation model, and unique key model, and duplicated model. This is an official document. I just highlight some of the key parts. So most of the data table is built on unique key model and a duplicate key model, and then we routing the data from Kafka and into Doris, and then we build our data model mostly using a unique key model, and build our materialized view using async materialized view, and then we have a multi-dimension analyst engine, which is Juno for serving blockchain data requirement. So we usually use star schema and snowflake schema to build our crypto data model. And then, as I mentioned from previous slides, we have quite a few materialized view. And we also have Apache Afro jobs. To give you some more details, we have almost 130 Afro jobs and 70 Flink jobs, and around 40 Doris materialized view to build a data solution. And this is a comparison from our perspective that is on performance-wise is quite fast for the Doris. It's easy to set up, and it's seamless within Doris system. And we build our complex workflow using DAG, using Python to build our Afro job, and then we migrate some of the Afro job to Doris. The benefit is easy to maintenance. The error rate, I guess, is much less than Afro job. It's only, I think, for 100 job, there are only less than 0.3 error. So it's quite easy to set up and quite easy to maintain. And also you have some benefit came from reduce the computation, especially those in your subquery. They have some duplicated replication, but you require you recognize and optimize your query carefully. And also, if you want it for a migration, so one thing you might need to import your data. The right-hand side of the slide shows us a comparison of different data input method. You can still fetch this charter from official document. We use mainly Google Cloud from our S3 source in BigQuery, in Google Cloud, and we use routing rows for the recent fresh data in Kafka. Few lessons we have learned to share with you guys is to for limit the size of the single files. If you want to import, it's less than 500 gigabytes and around 10 gigabytes. To merge small file for your migration, because I/O cost might slow down your whole migration process, and also limit the concurrent jobs, because you need to monitor the backend CPU and memory and the whole compaction, because compaction might causing your unstable issue. So you can choose according to your scenario. And when talking about compaction, the purpose of the compaction is to merge small file into large one during the some kind of operations, but it might causing other issues, as I mentioned. So a little bit of advice is to monitor the performance. I remember Apache Doris provided a lucky monitor to help us to easily monitor everything. So I advise you guys to adjust some of the parameters here, including mass-based compaction flag and others according to a scenario. So also avoiding a large-scale operation. Sometimes we need to delete something if we have some wrong operation. We need to delete something according to our partition. A little bit about future plan for using our current architecture. As you know, we have huge costs on the storage size, rather comparing to the computation size. So the computation, if I think it's only 1/3 of the total cost. So we wanted to migrate more to the lakehouse solution to support some of the scenario in the recent future. We have almost 10 times of the current storage. That means it's around 2,000 terabytes of a blockchain called Solana to support them. But the current architecture, after we estimate the whole cost, we can't support them because we're losing money if we support those blockchain. So we wanted to unify our system and simplify the management and for most of all kind of a cost saving. And so a little bit about lower the cost. As I mentioned before, we only have 10 developers and we are now break even, which is very important. The boss usually consider us a developer department as a cost center. So we have to do everything to minimize the cost. So I have some suggestions for minimize the cost. And the first thing is optimize the query. And this is the easy thing to do, but it requires more carefully to look into your system. And but the benefit is you have less cost on the hardware side, and including you have index or Bloom filter or leveraging the prefix index. Unfortunately, we can't use the prefix index because the prefix index has kind of a limited length. But usually from our side, we call you can see that we name that field is contract adjust or account adjust or just adjust. Wallet adjust is less than is quite about 40 of the string length, about 48 I guess. Most of them are about 48. So the prefix index limitation not fixed in our case. And also partition and bucket and also materialized view, which will reduce your computation costs. And choosing the right compaction is solved by the compaction ratio. According to your scenario, some of them mostly we're choosing Z standard, and sometimes we're choosing zlib, and keep monitoring your the whole cluster. And we use only one FE because the downtime is acceptable for us, and also we found that the FE once it restart very quickly. I think it's less than 10 to 30 seconds. And also we consider using lakehouse solution to most of our cut the costs. So that is pretty much everything for our slide. I hope you gain some insight from our part. In summary, that for the migration since Google Cloud, we support almost 30 blockchain, and that is almost double than previous before. And then we have low latency benefit. Previously is within hour or even 3 hours, some of the data. And then for right now, we have less than 1 minute for the latency for some of the table I mentioned about pricing and trading related table. But we are not a trading company, because a trading company has even less tolerance on the latency side. So, but the cost is even lower. So we save almost 1/3 of the total cost using a combination of the Juno and Apache Doris for our whole data solution. That is pretty much anything.